Good morning, everybody. Welcome back to Coding on Swiboe, the next generation text editor. And you know what? I don't have any top of the show business today. Yep, none. Absolutely none. Okay, so we can dive right in. We were working on the Python testing part yesterday, and we made nice progress on being able to actually run our tests and provide the arguments for the test. For example, which library to use, like which C library to use for testing, and which test server to use for testing on the command line. Right. So we have this beautiful test.py file now, and it actually takes a shared library argument where you can tell it to use this particular library, right? And then it will run and it will work. Unfortunately, what I figured out yesterday, which is really bad, is that if the tests fail, then our test server is never stopped, right? So let's have a look here. You can see there are 3 test servers running, and if I run this test now and it works, it stays with 3 test servers. But if I provide, for example, a library that doesn't exist, then suddenly we have 6 test servers. So apparently there's something that is going wrong here. And we kill all of them again, and then we can look into that. So what is going on? I thought that teardown was always called, right? So setup obviously works. It brings up the server. But apparently teardown is not working, and I'm really confused about that. I thought teardown was always run. So just to make sure that, let's double check that this is the case or not. Let's add some logging here, and I wonder if we will see this logging now. And apparently we don't. So that is actually really bad. So let's ask Google for that. Teardown Python not called on exception, something like that, right? Python unit test is wrong and teardown should always run. That seems to be a blog post. And for teardown, this method will only be called if the setup succeeds, regardless of outcome of the test method. See, that is our problem. Because basically what is crashing in setup is this part here. And obviously, if this crashes, then setup does not succeed, and so teardown is never called. So that's really bad. That is really bad, right? How can we fix that? We can maybe oh man, maybe we can kill the process when the class is garbage collected. I guess that would work. So what is the Python finalizer called? Is it called del? I think it's del. So let's try that and say, well, this is actually now like del. But I think that we actually have to call the superclass del. What is this? What is this? Finalize del. Do we have to call the superclass del in Python? Python superclass. Maybe you don't have to. Maybe that happens automatically. No, maybe not. Okay, So we call our process here, and then we call through to the superclass, and now this should work, right? Did it work? Let's kill all the test servers and try again, and then we'll see that it did not work. We still have many test servers, and they're getting more and more the more tests we run. That's sad. That's sad. So this is not working the way I was hoping to. Undefined variable. Well, of course this should be test Swiboe client low level, but apparently this is never called, so it doesn't really help me in any ways. I mean, one solution would be to not do that in the setup procedure at all. Another would be to actually catch this error here and turn it into a failure somehow. But none of them are really great solutions. I don't know. That really got me stumped. Python always run tear down. Something like that, right? What is this error saying? By auto use fixture, what is that? Oh, that's PyTest, something different. No. No, that is not working the way I was hoping it would. Well, I mean, oh, obvious, that's a simple solution, right? We basically move the library loading, we move that up to the very top, and if that fails, then the server process will never get started. And so all of the other stuff, though, could also fail, right? So basically, I guess not, right? If the server process comes up, then those two lines should also work, and this is actually the solution I was looking for, I guess. So if I run it now, no tests, no test servers stick around. Great. And that works too. Now we don't actually need this del anymore. It can stay tear down. And we don't need to, or maybe we do. Do we actually need to? No, I don't think so. We can just say, well, done, right? Yay, that's what I wanted. And it is working. Great. Okay, how do we continue now? How do we continue now? We could continue by writing more tests, which is definitely something we should look into. Especially we don't have a test for failures. Like we have a test for successful RPC, but we don't have a test for a failing RPC, and we also don't have the proper wrapping code for that yet. And we also don't have a test for a streaming RPC. I think we'll do that first, right? Let's write a test for a streaming RPC. Test streaming RPC self. Let's do a happy test first. So how do we start out? We need definitely two clients, one that calls and one that listens. Good morning, Quaker Rs. He's asking, or she, so how far away are you from being able to write code for Swiboe in Swiboe? Well, I would guess we are like 3 months or something away from that. There's a ton of design that I want to get right, so I didn't focus on actually implementing any of the editor functionality. And basically the next step that we will look into might be basic editing, or it might be like semantic parsing, right? So that you understand where you are with your cursor in the file, because I believe that this is a very important feature for doing like proper triggering of, for example, snippets, so that a snippet can be bound to a particular context, and not only a snippet, but configuration options and stuff like that. And I believe if we focus too much on the editor part right now, we might run into a design problem later on with that. But as far as I can think of, this is the last big thing that we need to get right before we can implement all the features that I have in mind. So yeah, TLDR is, I think, approximately 3 more months or so. Maybe less, depending on how many people contribute. Okay, we need a serving client, we need a calling client, which we just call client, and both of them are connecting, so this should work. And then we need, of course, a callback. This is our RPC, and that takes a server context and some arguments. And in that, it will actually, what does it do? It will send a partial update, something like self library Swiboe server context update, right? And that should only take a pointer to server context and some JSON. So it takes the server context and it takes, what does it take? Some JSON object. Update is count, like so. And here we do JSON dump string update, right? This will actually, I think that will work, right? That will actually send the one update that is count 1, and then we say update is now count 2, and then we say update is count 3, and while we're on it, we can just do it in a loop for I in range 1 to 4. Update is this, and then we call this, and that looks sort of okay. And once we're done with that, we actually have to finish this RPC, and we do that by finishing with some success, right? So the call result will be an OK value, and the OK value will be last, and last is just foo. And then we finish this RPC call. Very nice. And now we have to register that one, so that will look exactly the same as up here. And why not call it test.test, who cares, right? And now, oh, we actually can copy a lot of this. So let's copy this over here. And we already have a client, but I'd rather only connect it down here. And then we actually call this RPC, and now we expect some updates. How did that work though? I don't quite remember. I think it was receive, right? It should be called receive. There it is, receive. Yes, that's what we want. So basically what we expect is we call client we call the RPC, and then we get a client context, and this one we will then call self library Swiboe client context receive, and that takes the client context, and that will return us, what will it return us? A string, and we assert equal that the string is actually let's make it like that, right? We get a JSON object and we say JSON load string from what we get back here. And from this one we query the count variable, like so. And that should be 1. And this will be 2, this should be 3, and that should be it. And the last one that we get is actually none, right? We call receive on an RPC that is finished, so we should not receive anything anymore. And then we can query the call result. Let's do it in a second though. Let's try if this test passes. Expected string or buffer, it says. And where does it say that? It says it down here, because of course if we get none back we cannot call load string on that. And the test passes. Very nice. So then we wait for the final result, and the final result should be okay. And the JSON blob in the final result should actually be something like last, I think I called that, right? Yeah, it's up here. Let's pull it out so we can compare against, and then we can say, well, this should be last. And then we disconnect the 2 clients and this test is done. Last, please, not last. Okay. So streaming RPCs are done, and I think we don't need the main function anymore. That was the one I was copy and pasting from. And well, this to do I would like to keep around, but maybe let's keep it here. And I think we got this then. We're done. We already added that -v flag yesterday, right? And it's also working. Yes. And now, do we still have... Yes, we still have one no-com in here, and maybe we should look into doing that real quick. Should we though? This no-com is about the following, right? If we bring up the test server, it prints out one line that is the path to the directory that we should use for temporary files and stuff like that. And also that contains an underscore socket file. And my initial thought was that the test server should actually write out a JSON file into this directory, and then this JSON file should be loaded by the individual tests. But since the keys in the JSON file are just as much convention as naming the file underscore socket, maybe it doesn't actually buy us much until we really need more structured information, but maybe we don't need more structured information anytime soon anyways. So yeah, maybe we just don't do that. Maybe we just keep it like that and say, well, that's it. Okay, now let's go and clean up this file a little bit so we don't have this one. This is not used. And are they sorted? Yes, and all of them are used now. That seems silly too, right? We import something from Swiboe and then we import the Swiboe itself. That seems really unnecessary, especially since we only call the Swiboe library here once, so we can just do it like this, right? And now we have a couple of tests, and I think they're probably all that the functionality that we wrapped so far. I think so, at least. I mean, we can check that we actually use all of the functions in here, right? Swiboe connect and Swiboe disconnect we use your new RPC, RPC OK. We don't use RPC not handled, so this we need to test. We don't use this, so this we need to test. We call RPCs, that works of course. Then we call context wait and context finish. We don't call an RPC from inside an RPC. That's something that we definitely need to test. Result okay, result unwrap, receive. Yes, we just wrapped that, and then we have update, so we test that too. Okay, so just a couple of functions more that we need to test. The RPC not handled one is rather easy, right? All we need to do is like define tests call not handled RPC, and that will look very similar to this code. But instead of an RPC return, we actually return an RPC not handled. And that should not take any arguments, that is correct. And then we finish this RPC. And now, when we call this RPC, which we do down here, we just wait for the result, and the result is not okay. I think that's about all we can check here. And then we disconnect. So let's make the test fail first to make sure that it actually works. And I should never use ACID in those tests, I just realized. It should always be, oh, doesn't Python make a difference between ACID and equal? So what concerns me right now looking at that is ACID means, for example, in Java testing or in C++ testing, it means if this is not true, terminate the test here. And terminating the test here would be terrible because it means that our clients are never disconnected, which is not quite true because as soon as our server is being pulled down, those clients, of course, have to disconnect somehow. So maybe it's not that big of a deal. Yeah, I don't know. So this test should now fail, right? Because the result is definitely not okay. It should be something like not handled or so. And the test indeed does fail because false is not true. Thank you very much for that, Python. So this should actually be false, and now the test passes again. Really nice. Okay, so there was this that we tested, and now we have Swiboe RPC error, like returning an error, which will look very much the same, right? Instead of an error, though, we instead of not handled, we actually now have call erroring up, like RPC returning error. That's better. And here we actually not call Swiboe RPC not handled, we call Swiboe RPC error. And what does that take actually? It says that it takes 2 pointers. I don't remember how we did that. So let's look in the C client lib. So it takes a buffer error name and a buffer details. Oh, okay. So we have some sort of RPC error that we can construct from a string, right? Oh yeah, we can just say unknown RPC, invalid arguments, or IO error. Let's use invalid arguments for this particular test. So here we say we have an error, and that error is invalid arguments, and the second one is probably some sort of details. And the details should be a valid JSON object, so we just do JSON dump s, or actually let's pull that out and say error is, whoa, what's going on? There we go, details, needed foo got blah, right? Very detailed error information. And so we dump s here, this error thingy. So this creates an error and we return that, and then we call the callback again, and Yes, we call the callback, we don't pass any arguments, and then we wait for the result, and the result is not okay. So that should be very much the same. Unfortunately, we have no way of actually inspecting the error, so we should probably add a to-do here, inspect error, to see if it is what we expect. Wow, that's rather circular, so inspect error should be enough. And I think that's actually it, right? We don't have something like unwrap error or something. We only have result is okay and result unwrap, but we don't have any way of unwrapping the error object yet. So we need Swiboe RPC unwrap error or something. Okay. This test should pass. Let's make it fail first to make sure that it actually runs. Now it should fail. Failures 1, and if I undo that again, then it passes again. Really nice. Okay. So this is tested, and now we need a little more involved test, actually, where we have a RPC calling a RPC, right? So we can probably start out with this one and then say something like test call successful RPC from inside RPC. So we now need 2 serving clients. So the first serving client can just return the golden data. That is perfectly fine, I'd say. And now we need a second serving client. Actually, let's call this one serving client 1. And this callback we call callback 1. And the same for the RPC callback. We also call that RPC callback 1. And now we have a second serving client that connects, and then it registers another one that we call test foo. And what does that do? We need a second RPC, please. Right, so this is actually serving client 2. And that has a golden return 2. Something like that. And this is not callback 1, this is callback 2. And actually, I think we're nearly done because this is actually callback to 2, and we call the test call, we call it test foo, right? Okay, so now we registered 2 RPCs. Now we bring up a client. Oh, actually, this RPC here, that needs to call, right? It actually needs to call self library Swiboe RPC context. Not RPC context, but server context. Call RPC, right? That's how it should be called. And it takes the server context here, and then it takes the function name, which is test.test in here, and then it takes the arguments, and the arguments, we can just say, well, it just passes the arguments through. Why not, right? And that returns a client context on which we need to wait. And once we waited on that, we actually get a result back, and this is the result that we also pass through to the caller, like the original caller. Okay, and now our outermost client will actually call test.foo, so it will call this RPC, and then it will wait for the context, and what it will actually get back is the golden return 1, right? So we don't actually need golden return 2, and we can rename this again to golden return. And with that, we should be golden, right? I think so. We wait for the result, we check that it is okay, we unwrap it, and then we say it's golden, and then here we actually have to disconnect the serving client 1 and the serving client 2. And with this, we should be done, right? So this is now tested too. Beautiful. Now what I want to test real quick is if it's also working with a release build. And I also want to know if it's actually faster. And once we're done with that, I will actually cut the stream, because we're 30 minutes in already, and 30 minutes is a good time. And tomorrow we look into unwrapping the error streams, right? Doing this here basically. So let me turn that into a no-com. Because that is something that needs to be done before this is actually production ready. And once we've dealt with that, we still have to deal with a bunch of error handling, which is something that I'm not looking forward to, but we need to do it. Like, for example, our connect call, right? It returns a client, but what happens if the connect fails? Right now it will just return whatever. I'm not quite sure actually what it will return. But definitely we have no way of inspecting that for errors. So I basically believe that we need to change our full API to never return pointer types explicitly, but instead always return integer codes, and those integer codes will map to errors, and then we'll add one more function that allows you to turn an error into a string to show to a user. And then basically all of this code will look rather silly. It will always be, oh, if this function call is not 0, then do that and that. If this function call is not 0, then do error handling. But that's the most stable way I know to actually dealing with errors in C libraries. Okay, so this compiler is done. That is actually which one? And the C client. So we also need to build our test server in release mode. Doop doo doo. Oh, I wish Rust would compile faster. It compiles very fast compared to C++, but, well, working in Python and where you don't have to compile at all, yeah, that's really nice. Let's try PyFormat again. And what did you do? Nothing. Didn't change anything. Okay. So this is done. Back to our C client, and then we can now call our tests. And we want to pass in the shared library. And that is target release libswiboe. And the same goes for the test server. That is target release test server, and let's see what happens. And all the tests still pass, so that's really nice. And comparing the performance is rather interesting too. So if I now switch that back to using the debug versions, how much slower will it be? That's quite significant. Look at that. Like, the debug version takes 0.4 seconds for our 7 test cases, while the release version is only taking like 40% of that time. And that seems to be pretty reproducible too. Interesting. I wonder why the debug version is so much slower. Well, who knows? We don't have time to investigate that right now. So I'll finish the stream here. And as always, if there are more questions, I'll stick around in the stream chat. You can always find me also in our Gitter chat room. And tomorrow is Thursday. Yes, tomorrow. What do we do tomorrow? I think we'll look into this NoCom and then we'll start on error handling. And once we're done with that, the C ABI is in good shape. And either we then write a proper Python abstraction over that feels Pythonic and whatnot, or we do something else. We'll see. A quick reminder, next week there will not be any stream. And I'm also still waiting for more feedback if the streaming is useful to you people, if you enjoy watching it, if I should continue doing it. Today, by the way, is our 21st stream, so I have been doing that now for more than a month, which is kind of crazy. Okay, thanks for watching, and I'll talk to you people tomorrow.